All right, we'll also be talking about solving logarithmic equations. Okay, and these are a little bit like the exponential equations. You still have to know some of your logarithmic properties. Okay, so let's take a look at, let's jump right in and get an example. Let's say 7 plus log base 3 of 5x minus 4 equals 10. So once again, do not forget to just do your simple algebra. Okay, just because we're talking about logs and exponentials, things like that, this is still algebra class, and we still need to go back to our basic week 1 algebra 1 stuff. Okay, so I need to solve for this log. So I need to get it by itself. So I need to subtract 7 on both sides. All right, and so I'll be left with log base 3 of 5x minus 4, and that will equal 3. And if we remember what a logarithm is, right, this is my base, this is my answer, and this is my exponent, right? So we really have everything we need as long as I have this, just the log set equal to a number. Okay, so I can say that my base is 3. So I can say 3. And let's see. It's this 3. So I can say 3 to the third power. And that 3 will be my answer over here. And that all equals 5x minus 4, which is obviously just from straight down. And 3 to the third power is 27. 3 times 3 is 9, times 3 is 27. And 27 equals 5x minus 4. And once again, I'm solving for x, so I need to add 4 to both sides. So 31 equals 5x. And then to get x by itself, I just divide both sides by 5. And so x equals 6.2. You can do that in the calculator. 5 times 6 is 30. 5 times 0.2 is 1. That will give you 31. So x equals 6.2. All right, so that was pretty simple. Let's try one more. This one's going to be a little bit more difficult. Not too much. All right, let's say log of x plus log of x plus 9 equals 1. Now, in this case, we're going to have to remember our properties of logarithms. And if I look at my bases, they're the same. And remember, when I don't have a base showing, that means my base is 10. So I'll just go ahead and write that down so we don't forget. And since they are the same base, I can use my product property. And my product property tells me that when I have the same base, I multiply what's inside my logarithm. So I will have log base 10 of x times x plus 9. And we're going to have to distribute that x through, so I'll add an extra set of parentheses just so that we don't forget. And x times x is x squared, so I'll have log base 10 of x squared. And x times 9 is 9x. It's going to equal 1. Okay, and now that I have just my log set equal to a number, now I can say 10, because that's my base. 10, again, right there, to the first power equals x squared plus 9x. And 10 to the first power is just 10, so 10 equals x squared plus 9x. And I can kind of see that this is going to form some sort of quadratic. So if I want to solve for a quadratic, I need to set it equal to 0. So I'll subtract 10 from both sides. And so I will have x squared plus 9x minus 10 equals 0. Now, there's obviously a different few different ways you can solve quadratics. The easiest way is to see if you can factor it. And so to factor something without a lead coefficient, I will look and see what are my factors of -10 that add up to +9. And if I think of my factors of 10, I have 1 and 10 and 2 and 5. And one of these will have to be negative, right? Since I have a negative coefficient or constant back there at the end. All right, and so that being the case, I think about it and I say that, well, 10 times -1 is -10, and +10 minus 1 is +9. So I have x minus 1, and I have x plus 10. And then when I set them equal to 0, I can say that x minus 1 equals 0. So add 1 to both sides, so x equals 1. And I also have x plus 10 equals 0. Subtract 10 from both sides, so x also equals -10. So I have x equals 1 and -10, and you say, okay, I'm done. But it's always a good idea, especially with quadratics, to double check your work. And if I just take a quick glance back up to the top up here, and if I just plug in my x values, real quick into my first portion of this equation, well, I see that log base 10 of 1, so we can go down here and say log base 10 of 1, well, that equals 0, because 10 to the 0 power is 1. Okay, and then I can also see that log base 10 of 10, because 1 plus 9 would be 10, is 1, and 0 plus 1 is 1. So that's true. This is going to be a true statement. Okay, that one's correct. That one's going to work. But then I see my -10, and if I plug in, let's see. If I plug in my -10, all right, I'm going to have log base 10 of -10. And what does that equal? 10 to the what power gives me -10? Well, if we think about it, there really is no exponent I can raise a number to give me a negative value, right? There's nothing that I can put in an exponent above 10 to give me -10. So that being said, cross that out. Cross out my -10 up here. My only x value that works, and that is true, is x equals 1. So as long as we remember mainly our product properties and our quotient properties, things like that, we still have to be using these logarithmic properties. Solving logarithmic equations isn't too difficult. Just have to make sure we're doing the simple algebra 1 things before we get too caught up in the algebra 2 things such as logarithms. All right, that'll be it.